All right, so I said I would try to do a whole bunch of lesson sets. And it's kind of getting late on a Sunday night. So I don't think I'll talk concept too much in this lesson set. Hopefully tomorrow morning, I can make another one and doing the same problems that were in lesson set 2. All right, except I'm changing the numbers. So I probably talked a little bit about concept in that lesson set. So I hope I did. I know I need to do a whole lot more, but because of the hour and because it's a major project here, I don't think I can do much more than just do the problems out. So you can pause the video and you can work right along with me and at least follow the mechanics of what I'm going to do. Each lesson set, I hope to talk a little bit about process. And so I will talk a little bit about average rate of change in the next 10 minutes, and I will do a series of quick 10-second graphing forms. And so let's have at it. And you can look at and think about the patterns that emanate from this process. And hopefully, as I say, in the next lesson set, I'll take more time with the problems on the board. All right, so I'm going to make a linear function out of these two coordinates. And so I'll make a 0 first out of the number 3. I'll add 11, and that is going to get me a y value if I plug 3 in. I get 11, so there's correspondence. Now when I plug 8 in, right here, when I plug in 8, looks like I get 5, and 5 plus 11 is equal to 17. Oh, it's not equal to 17? Oh, so that 5 didn't work, huh? I guess I better get rid of it. Let's get rid of that 5. Now it's the number 1. I can multiply 1 times whatever I need to get from 11 to 17. Sure looks like it's a 6. Quadratics. Smallest area you can get in a square is 0. So I want 3 to act like a 0 geometrically. So there we have it. Looks like there's a little similarity between the two. And of course, when I drop a 5 in, I get 6. Oh, no, I don't get 6. When I drop an 8 in, excuse me, I don't get 6. I get 25. I guess that doesn't work. Why don't I get rid of it? I suppose I could write that as 5 squared, huh? Well, let's get rid of that 8 minus 3 squared, because to get from 11 to 17, you got to go up 6. That's that equation. Of course, if the square area is 0, then that means that the square root, which is the side of the square, keeps getting smaller and smaller and smaller. I can make that square all the way go to 0, and 0 times 0 is 0. So a square root function looks like this. A positive square root function looks like this, and 0, the square root of 0 is 0. And that's the smallest square root you can have. You can't take square roots and negatives on René Descartes. I've got the card over here. Computer's on René Descartes. So I guess I gotta make this a 0. Yeah, I can do that. And it's a square root function. And I want 11. I guess that's my y value. Of course, when I plug in an 8 in here, I get the square root of 5 plus 11, which equals 17. Oh, no, you say it doesn't. Oh, well, let's get rid of the square root of 5. Let's get rid of it. And let's add 6. That's this function that passes through 11, 3, 11, and 8, 17. And I said I'd talk about average rate of change. I haven't done that yet. The average rate of change between those is the slope of the line segment that connects those two. And I think to get from 11 to 17, you got to change by 6, and from 3 to 8, you got to change by 5. Guess you could see that. And over here, so this was the squaring function. So this is over here we have 817, and we have 311 here. And so it's the slope of that line that connects those two dots. 11 to 17 is 6, and 3 to 8 is 5. Jeez, that's 6/5 too. Not interesting. And of course, over here, this was a line. So how do I get from here to here? I think 6/5 here as well. Interesting. Absolute value. Absolute value measures distance, and I think the smallest distance you can from 0 on a number line The smallest distance you can travel from zero is to stay put at zero. Don't travel at all. So I gotta make the 3 equal to a 0, so I guess it's x minus 3. I don't need parentheses because an absolute value is parenthetical in nature. And I gotta get an 11. It's gonna get me my first y, and that's gonna be a V shape up. Here's your 311 right there. And 817 is over here. 817 is over here. And I know when I drop an 8 in, I get the absolute value of 5 plus 11, which equals 17. Oh, you say no? Well, I guess you got to get rid of that 5. How do I get from 11 to 17? 6. So what's the average rate of change from there to there? 6 to 5. Let's do an exponential function with an asymptote of y equals 2. It's going to look like this. And I'm going to go through 311. And I'm going to go through 817. But I got news for you. That 11 is going to act like a 9. And that 17 is going to act like a 15 because I'm not measuring from 0. 2 to 11 is up 9. And 2 to 17 is up 15. Okay, so those are called differentials. I'm not going to show them, but that's what they were. So I got 3 y values. The most important one is 2. Everything's above 2. The next one I see on the left is 11. And then I see 17. So why don't I write the numbers 2, 11, and 17? So y equals 2, the number 11, and the number 17. And that's what starts exponential functions. And I think I'll make this 3 into a 0. So let's do the math. 3 minus 3 is 0. Anything to the 0 is 1. 1 times 9 is 9 plus 2, 11. Then let's drop an 8 in. 8 minus 3 is 5. I don't want something to the fifth. I'll make it to the first. Okay, so if I divide by 5 now, it's to the first power. It didn't affect the 3. It's still 0 when I plug a 3. So 8 minus 3, 5 over 5 is 1, which means I get that base. What happens to the 9s? They cancel. 2 plus 15, 17. Looks like I'm done. Let's do the inverse of that. What's the inverse of y equals 2? X equals 2. We're coming over here. What's the inverse of 3 to 11? 11 to 3. What's the inverse of 17 to 8? 8 to 17. Now let's start with our y values, which happen to be 3 and 8. Hope you can see a 3 and an 8. And x equals 2. So this is a logarithm, so I better graph this for you. It doesn't have any meaning for you yet. You've got to start these conversations. So there's 11 comma 3. How far is it from 2 to 11? Oh, coincidentally 9. And 17, 8. 2 to 17, coincidentally 15. Huh. Boy, I think I've seen those differentials before. Yeah, I think I saw 2 to 11, 9. 2 to, gee, it seems to be showing up again. Must be a coincidence. All right, this is a logarithm. And I need positive numbers here. And when I drop 11 in, it's 0. And I'm not going to get any answer. I need a number bigger than 11. So why did I put 2 here? X equals 2. Oh, excuse me. I should have been looking here. Not going to start again. X minus 2, right? So when I drop a 2 in, I get a 0. I need something bigger than 0 because logarithms are the inverse of growth and decay, right? So I've got my growth stuff and decay stuff here. Growth stuff, quantities, petri dish full of bacteria, radioactivity. I need something there to work with that's growing or decaying. 0. Pretty hard, if you go out there and you don't plant any seeds in your garden, you might get some weeds. So what's a better analogy? You don't want to put any bacteria in a petri dish and you put it in a sterile environment, I think you're going to take a long time to see it start to grow. How's that one? Is that better? All right, so now when I drop an 11 in, I get a 9. Right? When I drop a 17 in, I get 15 over 9. And that seems to be the inverse of this exponential base over here. Instead of exponential growth and decay, time to growth and decay, over here we have growth and decay back to time. Interesting, I think. All right, sinusoids. You have no clue what I'm about to do, but I'm going to do it quickly and easily, which means that there must be something that makes me look at this and go, oh, y equals 35 plus 15 sine 1, 2, 3, 4, 5, 6, 7, 8, 9 pi. 9 pi over 1900 to 2025, 125 years, provided I make 1900 a zero. Then I start at pi over 2. Okay? Can't be rocket science if I just look at it and can write it based on the numbers that are there. So we'll be doing that. Now it's time to do lesson set 3, which is the same as lesson set 2. So I'm just going to do the mechanics, equation of the line. You want to see if you can do it right? Pause the video. Every time I go to another problem, pause the video and try it. Otherwise, just watch me mechanically do it. Your brain's going to be moving in the right direction just by following. Okay, and 4 days later, by lesson set 5 or 6, hopefully I can talk about this stuff tomorrow in depth, or certainly at least give some ideas as to what's going on. All right, 8, 5. X minus 8 plus 5 gets me my y values. When I drop a 19 in, I get 11 plus 5, which does not take me to 9. I get rid of that 11 units of change. And from 5 to 9, I want to go 4 units of change. I have 3 coordinates for this function. Let me get rid of this. Let me get my trusty eraser. I'm coming back, moving slowly here. Coming back and moving slowly. So if I can go from points to an equation, I should be able to go from an equation to a couple of points, which means I should be able to graph this line with ease. All right, so what coordinates do I see? I see a 2 gets me a -3, so I'll do it this way. And I see that my x is changed by 5, so I'll go 7, 12, 17. My y's go down by 3, 0, -3, oh, down by 3, excuse me. Tired brain. -6, -9, -12. All right, let's check and see if that's true by putting 17 in. 17 minus 2 is 15. Oh, how lucky we are, because 15 is a multiple of 5. Oh, we're so lucky. Oh, I hope that happens again. -9, -3, -12, it works. Solve. No, 3 coordinates. Oh, so I just was supposed to do mx plus b with them. We'll do 3 coordinates here. No, we'll do mx plus b for this one. Doesn't matter, you get the practice in one way or the other. Mx plus b, so I got to multiply by -3/5 times x. I got to multiply -3 times 3, which is -9, and then I got to divide it by 5. And I got to add 7, but I better make it something over 5 or I can't add these things. I think that's 35 over 5 is 7, and I want to add. I think mx plus b was -3/5 x plus 26/5. Oh boy, is the brain tired. This is gonna be fun. All right, so now we're solving this. Well, let's find out what the answer is gonna be like by taking a graphical approach. Why do I do that? Because I want you to know that equations you're solving at the high school level are the intersection of 2 graphs. 2x minus 14. So let's call this -14, going up 2 over 1. It's about the right ratio of change. 24x minus 3. Well, -3 would be there. 24 to 1. 24 to 1. Wow. I'm going up pretty quickly. It looks like my intersection is there just to the left of the y-axis. Better be a small negative number. Otherwise, I made a mistake graphing or I made a mistake solving. But because I've done it 2 different ways, if it matches up and I'm on a final exam, I don't think I'd take this for this problem, but I could check it. I don't like dividing by a negative, so I'll take positive 2x, subtract 2x. Instead of subtracting 3 on the right, I'll add 3. And it looks like I get -11 over 22 as my x value, which happens to be a small negative number, which matches up with the graphic. Now I want to get a perpendicular to, I'll rewrite this. 2x minus 5y is equal to 4, and I want a perpendicular through -1, 4, which means I'm going to write x plus 1 plus 4 over here for my y values. And I know the slope is -5/2. Why do I know that? Because I've done 100,000. I probably have. I think I've done about 300,000 quadratics in graphic. I don't know what I'm looking at. And I just look at that. I know that's my answer. But let's prove it to you. First off, if I go over 2 and down 5, I've got a line that looks like that, and the perpendicular has to go up. Right? Oh, so that was the perpendicular. This line's got to go up. Makes sense if two things subtract out to be a constant, like 5 minus 1 is 4, and 6 minus 2 is 4, and 7 minus 3 is 4. They both seem to be increasing. So a subtraction in standard form means I have a line that's going up. So let's actually look at over 2 down 5. What's this one? This one appears to be over 5 and up 2. Of course, I erased it. So 2x minus 5y equals 4. I don't need to play with this 4, but I will move it to this side. I will move the 5y to the other. I will divide by 5. And I get a new line, and I want to know the rate of change. Then I'm looking here. So what's perpendicular to over 5 up 2? Down 5 over 2. Oh, there it is. There's the perpendicular. Okay, and now I've got this going. All right. So now I got a function. F of x equals 5/4 x plus 3. And I want to find f of minus 2. F of minus 2 means just plug it in, the input. And that's equal to minus 10 over 4. I could reduce it, but I'm just going to go 12 over 4. That's 2 over 4. That's a half, because then I didn't have to use my brain. All right, now I got f of x equals 12. Well, if f of x equals 12, if a equals b and b equals c, then I guess they are equal. So I guess if I'm looking at f of x equals 12, I'm solving this equation for 12. And what's the first thing I'm going to do? I'm going to subtract 3, I'm going to multiply it by 4, and I'm going to divide by 5. And that's how you can do problems in my class. You don't need to write anything there. I'm looking for you to think. All right. 4x equals 1 over 64. Guess you can see that, can't you? Yeah. All right, I'll do the work over. Nah, I don't like looking left to right. So yeah, I'll go right here. 4x equals 1 over 64. 64 is 4 to the 3. Where's that exponent? I'm looking for an exponent. I know it's got something to do with 3, but it's in the denominator, so it's a minus sign. Okay, so what's 4 to the minus 3? It flips 4 over 1. If I flip it, it becomes 1 over 4. And what's 1 over 4 cubed? 1 over 64. Now I'm going to rewrite this as a squared problem. I'm going to rewrite it. Okay? Somebody years and years ago figured out that 3 times 5 is 15. And then some joker said, I can make it a square and make it equal 15 by doing 4 times 4 minus 1. That's completing the square. It's really taking the average of the roots of this rectangle. X times x minus 8. All right, what are the roots? What makes a 0? Well, it sure looks like an 8 makes a 0, which gets me 10. And a 0 gets me 0, which gets me 10. That's a parabola going through 0 and 8. So what's the most important number? 4. That's what we get for a shape from x squared graphs. And this is an x squared graph. Okay, so that means that I could have written this as a square, where it's now x minus 4, x minus 4. That gets me x squared minus 8x plus 16. And this gets me x squared minus 8x. There's some similarity. I just don't like that 16. So I'm going to subtract 16 and add 10. And that means that x squared minus 8x plus 10 could have been written as x minus 4 squared. That's what I have, squared, minus 6. You don't believe me? Let's throw a number in and find out. if I don't make a fool of myself. 1 minus 8 plus 10, if I throw a 1 in, that gets me 3. 1 minus 4, negative 3 squared is 9. 9 minus 6 is 3. Geez, it worked for a random number. That's a good thing. So let me do it very quickly. X squared minus 8x plus 10. I am going to write x squared. I'm going to take minus 8. I'm going to cut it in half. Minus 4 squared gets me 16 units. I do not see the number 16 floating around here. I'll get rid of it and add 10. That's the completing the square process. So hopefully it's in your head a little. And if I make you do it every day until May, you're going to tell me you can't learn that? I hope you can. Gonna try. All right, 15x to the 6th minus 10x to the 4th over 5x cubed. All right, we're gonna just rewrite it and simplify it. So let's look at a situation whose answer we know. 6 plus 4 is 10. And what's 10 divided by 2? 5, you say. You'd be right. Why? Because 6 divided by 2 and 4 divided by 2 equals 5. And dividing by 2 is the same thing as multiplying by a half. And you wouldn't forget to distribute it. You wouldn't forget to distribute this multiplication. Then don't forget to distribute the division, because division is a form of multiplication. So I'm going to distribute it. And then I'm going to simplify it. I hope everybody knows how to reduce a fraction. That's 3. And if I have 6 in the numerator and 3 in the denominator, I have 3 more in the numerator. And 5 into 10 goes twice, and there's 1 more in the numerator. And I don't have to write that one, but I did. All right, f of x equals 4 times 5 to the x. And I want to find the inverse. So this means the inverse. Okay, and I think we talked about it in lesson 2, I think. You know, if I move my hand to the right and then up, the inverse is to come down and move over. So in this function, we do the hardest thing first and then the easiest. In the inverse, we're going to do the easiest and then the hardest in the inverse way. So it's kind of like solving an equation for a number. Except we're going to say that number that we find is really x. What's the first thing you're going to do if you knew a number? Say that's a 2. 5 squared 25 times 4. That's the last thing I did was times 4. So the first thing in the inverse I'm going to do is divide by 4. And what's the inverse of 5 to the x? It's actually log base 5 of x. Right? 5 squared equals 25. Log base 5 of 25 equals 2. Here, x gets that y. Here, this x gets that y. They're inverses. So what's the inverse of 5 to the x equals this? Log base 5 of that. Now let's put 100 in and see if it comes back as a 2. 100 divided by 4, 25. What's the exponent you put on top of 5 to get a 25? A 2. All right, can actually get this video done. Apologize for the speed, but at least it's something to work with. If somebody's out there having trouble getting into a school, and you can take the time to do these lesson sets, and it's not as good as being here having the conversations in class for 70 minutes, but it's doable. So 3x minus 2, if I square it, I get 9x squared minus 12x plus 4. Why do I know? Because I've done so many of them. You probably have to look at 3x minus 2 times 3x minus 2. Well, 3x times 3x, right? 3x squared. I think we can see that. What's minus 2 times 3x? It's minus 6x. Well, am I not doing that here and here? Am I not doing minus 2 times 3x twice? So here I got a minus 6x and a minus 6x if I FOIL. And minus 2 times minus 2 is positive 4. So when you square, you end up with positives on the ends. And whatever that product is, double it. All right. I don't think I've talked at all about square roots much yet, so let's start with 2 times 3 equals 6, something we know. 2 could have been written as the square root of 5, 3 could have been written as the square root of 9, and 6 could have been written as the square root of 36. Looks like a pattern here. So what's inside gives me what's inside. So the square root of 2 times the square root of 3 is actually the square root of 6. That's helpful. And I know that the square root of 9 is that side length, and the square root of 9 times the square root of 9 is 9. 3 times 3, 9. So there's a couple of things I know about square roots now. Does that help me here? Yeah, because multiplication is commutative. First thing I could have done was change the order. Right? And I think I know how to write 15 like this type of situation. Yeah, I think 15 is the square root of 5 times the square root of 3. And I think I know what the square root of 5 is. It's the number of times itself that gives me what's inside. So this is 5 root 3. And the memorization sheet I gave you, which I doubt you've looked at yet, square root of 3, you don't know, look at that sheet because you're going to work with that number for the next 3 or 4 years. Be nice if you knew the size of square root of 3. It's approximately 1.73. That's what we use in my class. Okay, so I actually know the square root of 75. Square root of 5 times square root of 15 is the square root of 75. Right? Which just happens to be the square root of 25 times the square root of 3. It's another way to get 5 root 3. It's quicker just to see it here. But there's one where you need to see what that is. So you got to practice there. What's the quickest way of doing that? Square root of 25 times the square root of 5. There's 5 root 5. Okay. 8, 2 is the vertex. Oh, isn't that nice? Is there something else I'm supposed to know about that problem? I don't think I wrote it down. Let me go look. I got the sheet. Number 16 without glasses. Also passes through 11, 6. So a vertex through 11, 6. I probably erased it a minute ago. All right. So if it's the vertex, then it looks like it's going up, cup shape up. I want that 8 to act like a 0. So x minus 8 squared, because the smallest square area you can get is 0. But I want it to be 2. There's our HK format. And now when I drop 11 in here, I get 9, and 9 plus 2 is 6. Oh no, you're right, it isn't. Let's get rid of that 9 units, and from 2 to 6, I should have written 4. It's that function. All right, so what are the answers to this one? Got to subtract 5. Got to divide by 3. Got to take the square root, which requires a plus minus. Let's see if it works. Let's drop. No, there's no reason to see it works. You can see it works right here. All right. What do I put on top of 1/9 to get that y value? What is that y value? I know it gets me a 3, which is 3 over 1. I guess I need this thing to be flipped, which is a minus sign, exponent. So now it's 9 over 1. And I think I take the square root of 9, and the square root of 9 is the same thing as 9 to the 1/2. So I guess I got to take a square root and flip it. Okay, now we're back to algebra 1 stuff. Real. A lot of that's algebra 1. Most of it is. X squared plus 5x minus 14. Not going to take any time with that. What numbers multiply out to be 14? 2 and 7. And if I want that to get me positive 5, then the 7 better be the bigger of the 2 numbers. Okay. How do I sketch 2x squared plus 12x minus 7? I know it's cup shaped up because the 2 is positive. I know on the swing side up, I've got my y-intercept, but you could always get the vertex first by doing minus b over 2a to get the x value. Minus 12 divided by 4, minus 3. And if I plug minus 3 in, should get a 2-to-1 opposite relationship from the first 2 terms. So 3 here is minus 3. Minus 3 is minus 36. So this better be 18 on the front side. It is. And then I've got -7, and so that's -18, -7, -25. Okay, wonderful, and I got the roots too. I can see the roots, my x values. I gotta start at -3 and move left and right. In order to get to a height of 0, I gotta go from -25 to 0. I gotta go up 25, and my a term is 2. And I need a square root. Okay, how did I see that? Well, I put it in graphic form, which is 2, because I can just take the 2. X plus 3 squared minus 25, that's this function. And I set it to 0. So what do I have to do? Thousands of these. Yes, I said, oh, I gotta go 25 units. Hey, yeah, from -25 to 0, I gotta go 25 units, yep. And if I'm multiplying something, well, let's actually do this out of different. Let's do it this way. Plus 3 squared minus 25 equals. Well, what does this thing have to equal in order for that to be 0? It's got to equal 25. Right? So that's why you're moving the 25. Right? So it's moving. So it's gone. I'll come back to it. Now I have 2 times something in parentheses squared equals 25. Well, this thing better be 25 over 2. Better be 25 over 2. So I got to divide by 2. And now I have something squared, which equals 25 over 2. I better have the square root of 25 over 2. And it could be positive or negative because when I square something. So I just saw that. And if your answers, if this is where we were, and the answer turned out to be -3 plus or minus the square root of 25 over 2. Well, it seems to me I don't have to do the work. How to do that is embedded in the problem. So keep your eyes open and you won't have to work. No need for the quadratic formula, no need for inverse operations. You can look at it here. And we'll keep talking about it till it makes sense to you. All right, so where am I? I am rambling late on a Sunday night. All right, SF. Standard form. All right, so I'm graphing this. That's how long it took me to figure out what that meant. All right, this is a linear function, but we do not need to change it into any other form. If it is a form already, you're supposed to be able to graph just by looking at it. And I can. And this is what I see. Not that I drew that to scale, but that's what I see. What did I use? I used zeros. I put a 0 in for y, I'm solving that. If I put a 0 in for x, I'm solving that. I get my intercepts and I got the graph. So standard form, when you got something like ax plus by equals c, or the textbooks like to make it harder, ax plus by minus c equals 0. Why? I don't know. But that's what you do. You get your x and your y intercepts. All right, there's only one way to get, we're going to factor this. There's only one way to get 2a squared, if it's factorable, is 2a times a. Now I could put a 5 here, but 5 times 2 is 10, and 10 and 1 does not appear to get me 7. So I hope if I switch them around, I can make the number -7. If I put a 5 here and a 1 there, then I get 5 and 2. Oh, that's 7. And the product has to be positive while they have to be negative. I think I want 2 negatives. Takes practice. If length times width times height equals volume, and I have no volume, then I either have to get rid of the length, get rid of the width, or get rid of the height. Crush the box. What crushes length? -4. What crushes width? 8 over 33. What crushes 2x plus 11? Minus 11 over 2. Hope you're pausing the video before I go on a rampage here. All right, so now we have y-intercept. Y-intercept means I let x equal 0. All right, what's the exponent you put on top of a 2 to get an 8? that log, that exponent right there is a 3 times 5 plus 10, 25. You're looking at two functions, and now you want to do f of g of 2, which is the same thing as f of g of 2, in case you spot that on your SATs. So we got to do g of 2. G of 2. Plug 2 in, do the math. 3 times 2 is 6, minus 5 is 1. So now we have to do f of 1. So we get to the f function. Here it is. We plug 1 in. 1 plus 7 is 8. Cube root of 8 is 2. 2 plus 4 is 6. So f of g of 2 equals 6. What's the inverse of this? Well, let's set it to x and pretend we're going to solve. Get this x alone. I got to add 5, and I got to divide by 3. That's my inverse. Was it f? Was it g? That's my inverse. Let's check your inverse. Let's plug 10 in. 3 times 10 is 30, minus 5 is 25. 10 gets me 25. Oh, please. 25 get me 10 over here. 25 plus 5, 30 divided by 3, 10. That's the inverse. F minus 1 of 4. This is the output of the original f function. So I'm going to take a shortcut. I'm going to set it equal to 4. So I got to do subtract 4, which gets me 0. I got to take 0 and cube it, which still gives me 0. And I got to subtract 7. So f minus 1 of 4 should get me negative 7, which means that g of 7, or f of 7, should get me 4. So let's do f of 7. Uh-oh, f of negative 7. Sorry. I scared myself. I don't want to make a new video. So what's negative 7 plus 7? 0. Cube root of 7. Cube root of 0 is 0. Plus 4 is 4. Yeah, I hope I didn't make any mistakes there. I am getting a little batty. All right, I guess you can see that well enough. All right, so Newton's law of cooling. So the room here is 60 degrees. It's been 60 degrees without any fluctuation the entire day, forever. Yesterday, tomorrow. It's always been 60 degrees, this room. It's always been here. But I poured a cup of coffee 5 minutes ago, and it was 140 degrees. And now, 6 minutes from now, it's going to be 100. I know it is, because I know Newton's law of cooling. And I made that halfway. So what's the equation? Well, 60 degrees. How do I get to 140? I add 80 degrees. How do I get to 100? Well, I don't add 80 degrees. I add 40 degrees to 60. And then time, I'll say t in this case, plus 5 over 11. And these are all about minutes. So let's throw minus 5 in. Minus 5 minutes plus 5 minutes is 0 minutes. 0 minutes is there's none. There's nothing there, just a 0. And what's 1/2 to the 0? I hope you said it equals 1. And what's 1 times 80 degrees? 80 degrees plus 60 degrees, 140 degrees. And that's your first taste of seeing some units change, convert. I'm converting minutes to coffee temperature in Fahrenheit. Let's throw a 6 in there. 6 plus 5 minutes is 11 minutes. What's 11 minutes divided by 11 minutes? The generic number 1. What's 1/2 to the 1? A half. What's a half times 80 degrees? 40 degrees plus 60 degrees is 100 degrees. Well, looks like you can write an exponential function pretty quickly. I don't think you need exponential regression. I don't think you need to put, not if you have the asymptote. If you don't have the asymptote, yeah, you got some problems. But we want to see where this stuff came from. Okay? I think the exponential functions were around before calculators were. Hope that's a true statement. Oh, I'm still doing problems. Yeah, starting to fall down here on my feet, but I'm doing problems. So now I'm doing this problem. I got to turn a 27 into a 1/9. I'm going to take the cube root. I'm going to do this conceptually. Cube root of 27 is 3. I got to square it to make it a 9. And I got to put that 9 in the denominator. So minus 2/3. So 27 is 3 cubed. to what exponent? 1/9 is 3 to the negative 2. So there's 3x equals negative 2. And there are the operations we need for an exponent on top of 27 to get 1/9. So let's put this on top of 27. Do the math quickly. This is day 3. So I'm going to take the cube root of 27, which is 3. And 3 to the negative 2, let's stop there and say 1/9. All right, so now I'm drawing a triangle in a coordinate system. The y value is -1/2. Hypotenuse will always be positive. And I want to find that x distance. So how do I do it? Well, I think -1/2 squared is 1/4. And I think 1 squared is 1. I think I need 3/4. I think that's my distance, is the square root of 3/4, that distance. 3/4 is the area, square root is that distance. And the square root of 3/4 is √3/2. And that's another one that I want you to learn, because you're going to be seeing that mucho times. All right, square root of 3/2. If you don't know, go look at your sheet. Read it every night. I'm using 0.87. Okay, can we agree that the square root of 3/2 is between the square root of 4/2, the square root of 1/2 is the square root of 3/2. The square root of 1/2 is 1/2. The square root of 4/2 is 1. What's a number between 1/2 and 1? Hey, it's believable. All right, now we're going to find distance. And I'm going to stick with this. This is a lot of work doing these lesson sets every day, but I'm going to stick with it. I think it's important. For somebody who's having trouble finding a classroom, you can do these. So 1/4. 1 is an x value. 7/5. 7 is an x value. I think I've gone 6 units. 4 to 5. 4 is a y value. 5 is a y value. I think I'm going up 1. I think I have a right triangle with 6 and 1. Maybe you're able to say 36 and 1 make 37. So what's the distance between those? Square root of 37. We're getting close to doing some trig in this class. Once we get that down, we can start doing some trig. All right. This, again, got to hear it, keep hearing it. What's the logarithm? Looking for exponents, I put on top of 1/5. And a log is an exponent. Equals means if the left side's an exponent, the right side's an exponent. So I'm putting the number 2 on top of 1/5, and that's going to equal 2x. So 1/25 equals 2x. And little known situation. If I want to divide by 2, all I got to do is put the 2 there. And that becomes 1/50. So divided by 2 is the same as multiplying by 1/2 on the left side. You can see that I can do that. 2 coordinates for the next value. 2 coordinates for this. Well, to get 8, I think I need to put well, let's put a 2 in first. Because 2, the cube root of 0 is 0. And 0 times anything is 0, so 2 gets you 5. And wouldn't it be nice if this was the cube root of 8, so it would cancel? So I hope that people can see that I can put the number 10 in here and get a nice easy answer. 10 minus 2 is 8, so I'm going to put 10 in. And now I've got this situation. And I hope you can see that that's true. Let's prove it. 4 divided by 2 times 6. I know 4 times 6 is 24, and then I got to divide by 2. But did you know that you could have put 2 into 6 and called that 3, and then multiplied by 4? If I'm not mistaken, both of those are the same answer. So I'm going to do the division first, then the multiplication. And 3 plus 5 is 8. And then you can start seeing data, get some visualizations going of, give me a couple of points on this graph. That's better than knowing nothing. Factoring. I forgot to do that in my last problem, my last lesson set. And I was reminded of what the answer should have been. Thank you. I'm not pronounce your name right, so I won't say it. So 12, 10, 2 is common. A3, A6, A3 is common. X9, X7, X7 is common. I gotta go from 2 to 12, I need 6. I gotta go A third to A third, I'm good. X to the 7th to X to the 9th, I need 2 more. 2 times -5 gets me -10. A to the 3 times A to the 3 is A to the 6. And I already got the X to the 7th covered. So that product is that difference. So what does it mean to take a difference and write it as a product? That's what factoring is. Okay, I wish we said sums and differences right as products. We don't. All right, almost done. Thank God. All right, here we go. Exponential function. I'm just going to write it quickly. Y equals 3. To get to 9, I need 6. The next time I don't need 6. To get from 3 to 15, I need 12. Looks like I got a doubling function. I want to make 0 and 1 up here. If I make this 0, I get 3 plus 6 because it's not 0, but anything that's 0 is 1. And 1 times 6 is 6. So 1925, I'll make a 0 by writing x minus 1925. And I think I have gone up 100 years. All right, so when I put 25 in here, I get 100 units. Divided by 100 is 1. 12 over 6 is doubling. So there's my 15. Square root function, we did it at the beginning. So x minus 5 plus 7. I've got to look at the change here when I drop 11 in. I get the square root of 6, which doesn't take me to 8. But from 7 to 8, I just got to go up 1. That's that function. Put it in Desmos or some graphing calculator. You'll get that. Solving this, I'm going to subtract 2. Subtract 7, which gets me 2. I'm going to divide by 2, which gets me 1. I'm going to do the inverse of log base 3, which is 3 to the exponent 1. And then I'm going to subtract 6, so I'm going to add 6, and that's going to get me 9. That should be my answer. Let's check it. 9 minus 6 is 3. What's the exponent? You put on top of a 3 to get a 3. That's a 1. What's 2 times 1? 2 plus 7. Bingo. All right, what are the roots? Got a new problem here. Okay, what are the roots? Well, I'll just give you the answer, and then I'll show you how I know. See, there it is. All right, so I know my x values are not 4. I got to move away from 4 to get to a height of 0. 0 is here, so my answers are imaginary. How far do I have to go from 7 to get to 0? Got to go down 7 units, and I'm multiplying by 2, so I got to divide, and I'm squaring. So it's got to be that. All right, and I'll actually take the time to show you. So I'll put this in graphing form. A is 2. I have 2 times x minus 4 squared plus 7. And I want that to equal 0. So I'll do it over here. You can see that. So I'm going to subtract 7. I'm going to divide by 2. I'm going to take the plus minus square root. I know square roots and negatives are imaginaries, and minus 4 becomes positive 4. Going to do that for several days. I don't expect you to learn it in 1 or 2 days. Okay, but look at it, a minute or 2 every day. Usually after a week or 2, most people get it. If they're looking at it, the folks that didn't look at it, they had to wait till the last 2 weeks of the term when they started getting worried and got to get more right answers. So look at every problem every day. It'll come to you quickly. All right, can I factor that? Yeah, I can factor it. So quadratics, if you can write them as products, you do. So I got x minus 10, or x plus 10, x minus 6 equals 0. So my answers are negative 10 and positive 6. So those are my 2 answers. All right, if you put negative 10 in, you do the math here. All right, so I got length times width equals area. I either get rid of the length or I get rid of the width. And if I get rid of one of the dimensions, I got no area. All right, x squared minus 4x. What was it? X squared minus 4x plus 10 equals 0. Let's do that. Oh, it's minus 60. Great memory, huh? That's why I'm retiring. All right, so let's do completing the square just to show you it's the same answer. So x minus 2, I don't know if you remember, but you cut that in half, you square it. Whatever that number is, get rid of it. So I'm going to get rid of minus 2 squared, get rid of it. And I got 64 here. Okay, and I'm going to come back to negative 10 and 6, I believe, or 10 and negative 6, I forget which it was. So now I have x minus 2 squared minus 60. This was a 60. Minus 64 equals 0. So let's do the inverse operations. There's 64. Oh, this had a 2 in front of it, didn't it? Didn't have a 2 in front of it? Or is that a different problem? Now I'm getting tired. Well, maybe that one didn't. All right, so this is 64. Now I got to take the square root of 64 plus minus 8. And then I got to add 2. Yeah, there's my 10 and my minus 6. Okay, so I got confused with another problem. I'm looking for exponents on top of m. Oh, I got exponents on top of m. Is there another way of writing this? Yeah, m to the minus 2. So what do I put on top of m to get m to the minus 2? Minus 2. Okay, so 3 times this. I wonder if I really had that 3 there. Huh, I don't usually put that there. So let's not, maybe it should be there, but let's just look at this. And this should be in a parentheses or a bracket. And I was forgetting to do that for the longest time. Too bad. All right, so what's the exponential activity here on top of m? Minus 15. Power to power, you multiply. All right, so m to the minus 3 is 1 over m cubed. And I'm dividing by 1 over m to the 6th. When you divide by a fraction, you multiply by the reciprocal, m to the 3 times m to the 6 over 1. And now we're just counting how many more factors of m appear, because m to the 6 could have been m to the 3 times m to the 3. What happens to these m to the 3's? They divide out, and I get m to the 3 as an answer. So when I see a problem like this, I like to move the negatives into the denominator, numerator to denominator as a positive. If my negatives are in the denominator, I move them into the numerator. And there's another way of seeing m to the 3. You could have done the rule. The rule is m to the minus 3 minus a minus 6. But you know why? Just move them and count. All right, last problem. I'm going to do it quickly. I guess I'm just going to sketch. Oh, it's not the last problem. All right, x minus 4. And this, why did we have to do this one now? Because this is going to take you a while. All right, so it's got to start there. Students have trouble with long division in Algebra 1. And I think if you do this enough times, then when you get a harder problem, then you make columns to keep track of your mental math. Minus 4x. I need minus 5x. I need another minus 1. Right? That gets me x squared minus 5x plus 4. Well, I got to get from 4 to 10. So I could put plus 6 here, and that would be true. If I FOILed that and added 6, I'd get that. But we move it inside. Then we write 6 over x minus 4, and that gets the job done. All right, there's ways to check this to see if it's right. And I won't do that today because it's a long video here. All right, so let's just look at that. What do you get when you do x minus 4 times x minus 1? You get x squared minus 5x plus 4. X squared minus 5x plus 4. So I did that multiplication. And this is a plus, right? What happens when I multiply these two things? So I hope you can see the x minus 4's cancel. And I add 6, which takes me over here. And last but not least, I'm going to just graph this quickly the way I like to. I'm on the upswing, so 0, negative 7 is here, which means I know this is negative. 8 into 40 goes 5. So I know it's negative, so I don't have to do minus b over 2a. I do it a different way. If I put minus 5 in, I get minus 200, cut in half, minus 7, minus 107. All right, so there are shortcuts. You generally don't take shortcuts until you understand a process, but it's really getting late here, and I'm getting tired. Okay, so let me stop that. I gotta let the video upload. Whew. All right. lesson 3 is in the books. See you tomorrow.